So hello everyone. In this lecture, we are going to discuss about De Moivre theorem. In short, we'll say this theorem as DMT theorem in complex number. Now next, see till now we have seen the different representation of complex number, right? The complex number can be represented in Cartesian form, means x plus iota y, or the complex number can be represented in r cis theta form, r cis theta, or in polar form, r cos theta plus iota sine theta, or in Euler's form, which is r e to the power iota theta, right? This much we studied. Now in this DMT theorem or De Moivre theorem, we'll learn how to find the power of any complex number. Means how, if z is any complex number, then we'll learn how to find z square, z cube, z to the power 4, z to the power 1 by 3, that is cube root of z, how to find fourth root of z, how to find fifth root of z, how to find cube root of z, square root of z, like that. So in this theorem, we are going to learn that how we'll find z to the power n. N can be an integer, n can be a natural number also. Got it? So first case we'll see when n is a natural number. So case 1, when n is a natural number. And in case 2, we will see when n will be in the form of 1 by 3. 7 by 3 means in the form of p by q, any rational number. Got it? So first we'll see. It is easy to calculate z they will give, right? It is very easy to calculate z square. We will multiply the complex number 2 times. It is somehow it is possible to calculate z cube also. But when the higher powers of z comes like z cube, z power 4, z power 5, z power 10, then it is difficult, right? So here we use DMT theorem. Now, here what we'll do, suppose any complex number there, z is equals to x plus iota y. So first step is we'll convert this complex number z in polar form. Polar form means r cos theta plus iota sine theta. Here complex number z they have given and they asked for z power n. So to find z power n, first we'll convert our complex number in polar form, right? After that, this z power n will be r cos theta plus iota sine theta whole to the power n. Got it? Now, according to this theorem, this z power n will become the magnitude of the complex number to the power n, r power n, and cos theta plus iota sine theta to the power n, right? Now, this n can be multiplied in the angle, means this power n, like this it will happen. Z power n will become r power n, and this n will come inside and it will get multiplied with the angle. So cos n theta plus iota sine n theta. Got it? How it is happening? For this, if I'll see proof, see, cos theta plus iota sine theta to the power n. Cos theta plus iota sine theta I can write as e to the power iota theta in Euler's form, right? And this whole to the power n they get. Understood? Now, if we'll apply the law of exponent, we can multiply this n inside. This one I can write as one is nothing but e to the power iota n theta. Again, when I'll convert this into polar form, it will be cos n theta plus iota sine n theta, right? So this is how it came. So whenever we have to raise any complex number to the power n, first we'll convert that complex number in polar form. After converting in polar form, the magnitude r power n will happen. It will be, see, we have to find z power n, right? So z power n will be equal to the whatever is the magnitude of the complex number, that power that magnitude will be raised to the power n, and the remaining this cos theta plus iota sine theta part to the power n will become cos n theta plus iota sine n theta, right? It is very easy. No need of multiplying this complex number n number of times, right? So we'll see this with some example. After solving these examples, we'll get more clarity. First question, we'll solve this one. They have given z complex number. Z is 1 plus root 3 iota, and they're asking for z cube, right? So first step is we'll convert this complex number in polar form. So here, first we'll calculate the magnitude of this complex number. So the modulus of this complex number will be 1 square plus root 3 square. Under root of 1 square plus root 3 square, this will be under root of 4, which will be 2. Which will be 2. Now next, and what is the argument of this complex number? The argument of this complex number, if we'll calculate, it will be tan inverse of root 3 by 1, right? Which is pi by 3, 60 degrees, right? Now, the polar representation of this complex number will be z is equals to r cos theta plus iota sin theta. So r value we got here is 2. This is my r value. So 2 cos pi by 3 plus iota sin pi by 3, right? Now they said to raise this complex number with the power 3. So I'll raise this complex number to power 3. Z cube will be 2 cos pi by 3 plus iota sin pi by 3 to the power cube, right? So here this cube I can write 2 cube, and then we'll get cos pi by 3 plus iota sin pi by 3 whole cube, right? So this one I can write as 2 cube, and this cos pi by 3 plus iota sin pi by 3 will I can write as e to the power iota pi by 3 cube, right? Now this will be z cube is 2 cube e to the power iota pi by 3 multiplied by 3, right? So 3 got cancelled. Simply we got z cube is equals to 2 cube e to the power iota pi. E to the power iota pi, if I want to write in polar form, I'll write it is cos pi plus iota sin pi. So cos 180 degrees minus 1, right? And sin 180 degrees 0. So here we can write z cube is nothing but minus of 2 cube, or z cube is nothing but minus of 8, right? Simply by applying DMT de Moivres theorem, it is easy to calculate. Now one more question we'll see. Suppose in this question they asked for z power 9. So if we'll calculate by normal method, we have to multiply this complex number z nine number of times, right? So instead of multiplying this complex number manually 9 times, what we'll do, we'll apply de Moivre theorem. Now see, z they gave minus root 3 plus iota. So first I'll calculate the magnitude. The magnitude of this complex number will be minus root 3 square plus 1 square under root of this. This will be under root 4 means 2. Got it? Now if I want to calculate the amplitude or argument, see in which quadrant this complex number lies. This complex number lies in minus root 3, right? So x coordinate is negative, y coordinate is positive, so it will lie in the second quadrant, somewhere here, right? This is root 3 minus root 3, and this one is 1. What is this angle? This angle will be 5 pi by 6, 150 degree, right? This angle is 30 degree. We'll see this angle will be 30 degree. So this angle will be 150 degree, or 5 pi by 6. Now, so we got the argument, we got the magnitude. Now I'll write this complex number z in polar form. So this complex number z I can write as 2 multiplied by 2 multiplied by cos 5 pi by 6 plus iota sin 5 pi by 6. Now when we'll raise this to the power 9, so we'll get raised to the power 9. So z to the power 9 we will get 2 to the power 9, and here cos 5 pi by 6 plus iota sine 5 pi by 6 to the power 9, or directly we can write this in Euler's form. So z to the power 9 is nothing but 2 power 9. Here this one I can write as e to the power iota 5 pi by 6. 5 pi by 6 to the power 9. So this one is z to the power 9, 2 to the power 9, and this 9 I'll multiply. So here e power I'll get iota 5 pi by 6 multiplied by 9. Right? So if we multiply 9 here, 3 2s are 3 3s are. It will get cancelled and we'll get 15 pi by 2. 15 pi by 2. So z power 9 is equals to 2 power 9 e to the power iota 15 pi by 2. Right? So now we'll convert it into polar form. So here we'll get the z power 9 is nothing but 2 power 9, and this will be cos 15 pi by 9, 15 pi by 2 plus iota sine 15 pi by 2, 15 pi by 2. So here z power 9 will be 2 power 9. Can you tell the value of cos 15 pi by 2? Cos 15 pi by 2 I can write as 7 pi plus pi by 2. Yes or no? 7 pi plus pi by 2. So it will be in third quadrant. So cos 15 pi by 2 value will be 0, as it is odd multiple of 90, right? So cos value will be 0 plus iota sine 15 pi by 2 is minus 1. Got it? So here we'll get z power 9 as minus 2 power 9, which will be z power 9 is nothing but minus 2 power 9 iota. This will be minus 512 iota. So this is our answer. With the DMT theorem, it is very easy to find any positive integral power of complex number. Now we'll see further rational powers, how to find if suppose any complex number is raised to the power 1 by 2 or 5 by 3. So how to find that values. So here, so case 2, when n value is p by q. So here, so what are the steps we'll follow here is, first of all, they will give, it is given that z value, they will give z value is x plus iota y. Now this asks for z power p by q. So step 1 is we'll convert this complex number in Euler's form or polar form. So this z I'll convert as r e to the power iota theta. Done. Now next step we'll do is they asked for z power n, right? Z power n means r e to the power iota theta to the power n. What is n here? N is p by q, right? So here to calculate z power n, we'll write this n in p by q form. So r e to the power iota theta, and here I'm having p by q. Now next, in step 4, in step 3, sorry, after this, in step 3, see, here only it is different from the previous case 1. See here the numerator part means which is p. P simply I will send inside. Got it? In next step. But this q directly I will not send inside. Means I will write here z power n is p. See p by q I can send. This r power I will write r power p by q here, and this e to the power iota p only I will write p theta, iota p theta, and 1 by q I will not send inside. Understood? See, if I will send this 1 by q inside, I will get only one solution, right? But in this case, In this case, there will be many solutions. Suppose if I said the cube root of a complex number, this will give three values. We'll get three answers for this. But directly when I'm multiplying this 1 by q inside, only I'll get one solution, remaining two solutions will be lost, right? So what I will do here, in step 4, this step is important. Till here it is easy. This p by q completely I'll put upon this r, and this e to the power iota theta I'll multiply only with this p, and this 1 by q I'll keep out only, right? Now the next step is to calculate this z power n. We got r power p by q and e to the power iota p theta, right? Here what I will do, in p theta I will add 2m pi. Got it? Then I will multiply this q inside by q. Got it? And now put m value as, now we'll start m value at 0, 1, 2, 3 and so on till q minus 1. So see how many roots will come. If the complex number is raised to the power 1 by 3, there will be three solutions possible, right? How we'll get that solution? By keeping m value as 0, 1 and 2. Understood? Suppose z value is 1 by 4. Sorry, power raised to the power 1 by 4 is there. So m value will keep 0, 1, 2 and 3 only till q minus 1. Got it? Now we'll see this with 2, 3 examples to get more clarity. Suppose this example here. In this example, they said that z is a complex number 1 plus iota. So now here first we'll find the magnitude of this complex number, which is equals to modulus of z. So this will be 1 square plus 1 square under root of 1 square plus 1 square, which is root 2. Next we'll find argument of this complex number z will be tan inverse 1 by 1, right, which is pi by 4. Now we'll write this complex number z. Step 1, what was step 1? To write this complex number z in Euler's form. So Euler's form is r e to the power iota theta. So here what is the value of r? Value of r is root 2 e to the power iota theta, means iota pi by 4. Got it? Now next they said to find z to the power 1 by 3. So z to the power 1 by 3 will be root 2 to the power 1 by 3 and e to the power iota pi by 4 to the power 1 by 3. This 1 by 3 will not multiply directly inside, right? Because when we are sending this 1 by 3 inside directly, we'll get only one solution. But here there will be total three solutions. Got it? So here get all the solutions. What I'll do first, in this pi by 4, I will add 2m pi. Then I will send 1 by 3 inside, right? So here I can write this z to the power 1 by 3 as root 2 to the power 1 by 3 and e to the power iota, this pi by 4, I will add here 2m pi and then I'll send that 1 by 3 inside. So I'll get this. And what is m value? So z to the power 1 by 3 will get total three values, three solutions for this. So first solution we'll get by keeping m value as 0. So keep m value as 0 here. So we'll get first solution is root 2 to the power 1 by 3 e to the power iota pi by 4 divided by 3 is pi by 12. Pi by 12. Next solution we'll get by keeping m value as 1. So keep m value as 1 here. If we'll keep m value as 1, we'll get 2 pi plus pi by 4, right? This will be root 2 to the power 1 by 3 and e to the power iota. What is, if I keep m value 1 here, so 2 pi plus pi by 4 is 9 pi by 4, right? This will be 9 pi by 12, sorry, 9 pi by 12, because this 3 is also inside down. Next we'll keep m value as 2. When we are keeping m value as 2, this will be 4 pi. So pi by 4 plus 4 pi. If we'll take this 4 as LCM, here we'll get 16 pi plus 1. 17 pi by 4 divided by 3 is 17 pi by 12. So here we'll get root 2 to the power 1 by 3 e to the power iota 17 pi by 12. So there are total 3 answers for this question. One is this, one is this, and another one is this. Now see, in these 3 solutions, we got 3 complex numbers, right? For all these complex numbers, the magnitude is same, right? Magnitude is root 2 to the power 1 by 3 or 2 to the power 2 by 3, right? Magnitude here is also 2 to the power 2 by 3. Magnitude here is also 2 to the power 2 by 3. The magnitude or modulus of this complex number here also is 2 to the power 2 by 3. And this argument is changing, the angle is changing. Yes or no? So if you will join these 3 points, every time you will get a regular polynomial. Understood? If you are getting 4 solutions, that means you will get a quadrilateral with all sides equal. Understood? If you are if the power is 1 by 5, you will get a pentagon, regular pentagon. If here we are having 3 solutions, so we will get a regular triangle which is equilateral triangle, which has all sides equal. So here if we draw, if I'll say this is my complex number Z1, this is my complex number Z2, and this one is complex number Z3. So Z1 will lie here, magnitude is 2 to the power 2 by 3, right? And the angle is pi by 12, means 15 degree. Next is next 9 pi by 12. 9 pi by 12 will lie in second quadrant, right? 9 pi by 12 I can cancel with 3, so this will be 3 pi by 4. 3 pi by 4, so it will lie in the second quadrant. Magnitude is same, 2 to the power 2 by 3, and this angle is 3 pi by 4. 3 pi by 4. Got it? This is 135 degree. Understood? 3 pi by 4 value. Now next, if we'll find the third one, 17 pi by 12. 17 pi by 12 will lie in the third quadrant. Here, the magnitude is same, like this. The magnitude here is 2 to the power 2 by 3. This complex number is Z3. And the angle here is 17 pi by 12. Got it? So if you will join these 3 figures, you will get a equilateral triangle. You will get a equilateral triangle. This one is Z1, this one is Z2, and this one is Z3. Done. And next one more question we'll solve. See, Z value they give minus 64, and they're asking Z to the power 1 by 6. So tell me Z to the power 1 by 6, how many solutions I should get? I'll get total 6 solutions for this, 6 answers for this. So we'll follow the steps. First, I will write this in Euler's form. In Euler's form, I can write what is the magnitude, the R value, the R value of this complex number is modulus of Z, which will come 64, right? And next, the argument of Z, will get is pi. Understood? So now next, because it is minus 1, right? So here it will lie, the argument will be pi, minus 64. It will lie on the negative x-axis. So now next, We'll convert this in Euler's form. So this one I can write as z is equals to 64 e to the power iota pi. Now we'll find z to the power 1 by 6. Z to the power 1 by 6 will be 64 to the power 1 by 6 and e to the power iota pi to the power 1 by 6. What is 64? I can write as 2 power 6. So 2 power 6 to the power 1 by 6 will be 2, right? So here we'll get z to the power 1 by 6 is 2 e to the power iota pi whole to the power 1 by 6. Now see, if I will multiply or if I will send this 1 by 6 directly inside, I will get one solution out of the 6 solutions. Understood? If I want to get all the 6 solutions, first I will add 2 pi, 2m pi, and then I will send 1 by 6 inside. Understood? So we will do here, first will z to the power 1 by 6. This I'll write as 2 e to the power iota, and pi is there. In pi I will add 2m pi, and then I will send 6 inside. Got it? Now what are m values? There are total 6 m values. So z to the power 1 by 6. So z to the power 1 by 6 we will get by keeping the m values. First we'll keep m value as 0. If I keep m value as 0, I get 2 e to the power iota pi by 6. Got it? Next we'll keep m value as 1. So here we'll get 2 e to the power iota. Here keep m value as 1. 2 pi plus pi, which will be 3 pi by 6. 3 pi by 6, which will be 2 e to the power iota pi by 2. Next, we'll keep m value as 2. If we'll keep m value as 2, we will get here 2 e to the power iota. Keep m value as 2 here. So 4 pi plus pi, 5 pi by 6. We'll get here is 5 pi by 6. The third one, fourth solution we'll get by keeping m value as 3. If we'll keep m value as 3, we'll get 2 e to the power, keep m value as 3, 6 pi plus pi, 7 pi by 6, iota 7 pi by 6. 7 pi by 6. Next, keep m value as 4. So here we get 2 e to the power iota. 4 means 8 pi, 8 pi plus pi, 9 pi by 6. 9 pi by 6. Or we can write this as, we can cancel the 3. 2 e to the power iota pi by 3 pi by 2. Right. Next, keep m value as 5. If we'll keep m value as 5, we'll get 2 e to the power iota. Keep here 5. So 10 pi plus pi, 11 pi by 6. Next, keep m value as 6. We will keep m value from 0 to 5. If we will keep m value as 6, again the first solution will be repeated. After this, if we will keep m value as 6, repetition. Repeated solutions will get. Understood? Again m value when we keep 6, it will be equal to nothing but m value 0 when we kept this. M value 7, again m value 1, solution will repeat. M value, if we'll keep 8, m value 2 solution will be repeated. This solution will be repeated. Understood? There are total 6 solutions. These are that 6 solutions. Now, if we'll plot this 6 solution on the paper, I'll get something like this. I'll get this. The total 6 solutions is there. That means 6-sided regular polygon I'll get. 6-sided regular polygon I'll get. If I'll draw this all, if I'll assume, suppose this one is z1 value. Suppose this one is z1 value. This one I'll assume as z2. This one z3. This one z4. This one z5. This one z6. And this one z6. That's it. So Z6, right? So here we'll get, see Z1, what is the magnitude of Z1? Z1, sorry, what is the argument of Z1? Pi by 6 means 30 degree, right? And the magnitude is 2. So if I plot, I'll get something, we'll get a regular XL. Here I'll get Z1, here is Z2, here is Z3, here I'll get Z4, Z5, and here Z6. And again, when I'll find Z7, Z7 will be equal to Z1. So Z7 here only becomes. That's why we don't keep the value of M more than 5, more than Q minus 1. Got it? As this is a regular, six-sided polygon, so all angles will be equal, right? So this all angles will be 60 degree. All angle will be 60 degree. Got it? Okay, thank you. Hope you enjoyed this lecture and your concepts regarding DMT is cleared. Thank you everyone. Jai Hind.